Yeah, so it should be working. Hey, we're testing it. Yeah, so it should be working. For a sec. Hey, we're testing it. Yeah, that seems to work. Hey, hello. Test, test, test. Yeah, that seems to work. Hey, hello. Test, test, test. Yeah, I think we're fine here. Yeah, I think we're fine here. We're good here. Yeah, so, hey there. Um, yeah, since nobody's watching for now, I will leave out the introduction. I mean, yeah, it's not necessary now, and that's why we're gonna be, yeah, I guess. We're gonna just dive right in and hopefully someone's gonna join, but yeah, again. So yeah, I think we could start. Yeah, some time ago, basically, I was interested in in cryptocurrencies, etc. And I was like, yeah, there are a lot of like scammers and pseudo traders, whatever, talking about some crypto and shit. And I was like, well, I'm an engineer actually, so there's no need for me. I mean, I want to understand things, and I well ask ChatGPT and other AI models about the about the blockchain, and I got like some basic answers, some like just average answers, aka well, it's an immutable chain of events, and well, there's proof of stake, proof of concept, sorry, proof of work, proof of stake. And I was like, yeah, and what does this do exactly? Well, you can store, you can store crypto, and you can transfer crypto, and and it's fixed, and it's instant, and it's decentralized. And I'm like, yeah, but how does it actually work? And they're like, yeah, well, there is a blockchain. I'm like, yeah, I got it. I got that there's a blockchain and it works, but how does how exactly does it work? And like, uh, we don't know. And in this moment, I realized I gotta do something similar to, well, to first of all to understand how it works. And this is the main thing, because you cannot work with something. I cannot work with crypto. I don't want to. I will not invest into it or something unless I know how it works. And that's the point of this stream, actually, to at least understand how it works. And the main thing is actually for me to just yeah, why am I gonna use Rust? Well, yeah, that's simple, because I do not know, I barely know Rust, and I wanna have some exercise. So I guess we could start. And for start, I guess let's define some structures. So there's this block structure. Um, it's gonna be a block. Oh, see, there is also a transaction, so it's already suggesting us, suggesting the block to us. But we're gonna be something. We're gonna go with something different. We're gonna have an ID hash. We're gonna go for yes. Uh, byte array. Yeah, we're gonna go with a byte array. Oh, actually, can I use byte? I just have to make a dry run first. Yeah. Um, can I use byte here actually? No, I'm gonna use the UA unsigned. Yeah, I think it. Yeah, there's just there's just a word. It's just a word length, so it's basically a byte. Yeah, we're gonna be hash. Gonna be a previous hash, which is gonna be a. Although actually I do not like the using vectors at the beginning because we have like fixed length, but move to fixed size array, and I want. Oh, by the way, actually, struct block header, and that's what we're gonna be doing. Yes, fixed size array. Yeah, that makes more sense. And a list of transactions, and yeah, what? Yes, transactions are using binary search tree, as we know. So what does a transaction have? Yeah, we're not gonna go with a vector here for transactions. That's not gonna happen. That's not gonna happen using transactions. A transaction is nothing but well, it's okay. Let's go with struct address. Huh? Why do we don't need nodes currently? We don't. Let's go with struct, yeah, transaction from to amount, yeah. We'll go now with it, but that's not what I would like to do actually, and we could actually use a state. So we gotta store this. We gotta store the state. Huh. I mean, there's we have basically nothing here. Okay, let's start digging in. So we can first of all the one thing I learned at the university is if you do not know the how a problem should be solved, the first thing is to try and write it down formally. I mean, how odd it may sound, but let's just formally a deterministic infinite, basically infinite automaton with f state and transaction is a new state. So we can formally. So now we have to define a formal, well, not so formal anymore. We can now define a function. And no, that's not a state. We have to state and transaction equals a new state. Yeah, that won't work. But what will is okay. Uh, let's make it account date. Access? No, no, that's not how it works. No, an account state has a 64 number of transactions. It has a float 64 balance. It has a storage root, I guess, or something. Chain. Balance, then oh, so there is a storage root. Oh, so basically you can store like additional information. Right. Okay. Contracts can have persistent storage, like one chain key value. So it's something key value. Global state would be instead each contract account as a pointer to its MPT. Yeah. Code hash, externally owned accounts. No. Yeah, so there's something for there is something for an account. There is something no, I mean there's some extra data for a smart contract to run, but we'll leave it for now. Yeah, so there's an account state. Yep, there's something we can. Yep, there's something we can go with. Yeah, there's this hash map of string and account state with account being, yeah. STT collection hash. Uh, main function, let's put it down there. So yeah. Hmm. Node state. Yeah, we'll leave it for now. Simple balance transfer logic. We'll leave it for now again. State updated. Yep. Yeah, for we won't directly use the transaction because we first collect the transactions and then apply them sequentially. Node state transaction. Oh, by the way, that transaction. Oh, by the way, yeah. Unix and the Unix timestamp. There's the Unix epoch. Here, yeah, there's something, and there's something. Yep. That helps. Now I'll get a hell of errors with, yeah, transition. Yeah, no, it's not state. Again, just delete it for now. Okay, huh? Oh yeah, there's borrow checker fighting here again. Yeah. So transaction is defined here. How can it be here if it's struct transaction? Similarly named struct transaction defined here. Oh, so you mean I just mistyped? Yeah, that was helpful. Cannot find transaction in this scope. Oh yeah, so step. That takes. Yeah, obviously. Yeah, so yeah, the state was updated, although there is not. There isn't. There are no states. Uh-huh. Accounts. Well, we could like add the blockchain for now. That's it. And And a blockchain here. And transaction pool. Yeah, we're creating vectors. It's empty. Yeah. Yeah. So now we gotta implement new. Wait a sec. Pardon. Now we gotta implement a new. Well, creating a creating accounts. So let me just do a quick research on it. Oops. We could, for example, node state. Oh yeah, that's easier. So what is an account? Well, I identity in a blockchain state. It's a unique identifier. Private key controlled by a person, obviously. Blockchain does not store your private key, only keep it. The blockchain stores the account ID, address, and state. Process in the modern blockchains is pick a random 256-bit number, like using a cryptographically secure range. When well, this is a private key. Or derive a public key. Derive account ID. Take the CAC hash and use the last 20 bytes. Right, so yeah, now we're getting somewhere. Yeah. Fuck me, we're gonna be working with cryptography. That rhymed itself even. So yeah, here's the backbone, and now we are at the account and basically the keychain creation. So again, we're gonna go with elliptic curve cryptography. Yeah, I believe it's the. I mean, we could have again like took a 256-bit number using a secure RNG and then derive manually the public key out of it. But I mean, does it make any sense? Since we are using Rust, I guess we can rely on it, and we can rely on libraries. I mean, that's I would have actually preferred doing everything myself to learn, but I'm by far not that good in math, so we will go with the standard functions now. Unfortunately, neither with Rust I'm good, so yeah. We'll go from here. We'll go from here. Oh, fine. Yeah, we're gonna be. No. Cryptography and generate keeper. We don't need random bytes, though we could use it. Yeah, we first create a private key, but according to the specification here, we should actually take the 256 bits, which is wait a second. Yeah. Wait a second, I gotta Google something. Yeah, I'm 32 bytes. This shit's correct. Yeah. Sorry, I was like, is it 256 bits? Is it 32 bytes or not? And yeah, it has to be. Yeah, so now this serious shit gonna go because use elliptic curve we have to derive the we have to derive the public key out of it, and again I'm gonna go with it myself alone. Now we're gonna be doing private key hex connect actually. Oh, oops. I guess we gotta import the hex encode. Unfortunately, again, I'm very unfamiliar with Rust and I'm trying to learn it. Yeah, let's ask an AI. Sorry guys, I know it's not how it should be done. I know that's by far not how we should be doing it, but again, I'm pretty unfamiliar with Rust standard libraries and yeah, but it doesn't solve anything. Yeah, let's try the grok. The other one. No, this main function printing the variable. I don't care about printing it. I do care about the hex though, which does not work and which bothers me. I mean, we could like little hex encode string. What's actually the result? The result is the vector of, yeah, the byte vector. Yeah, I think we can live with it for now. I think we gotta find a. It would be nice to find a proper Rust crypto module. I think. Wait, let me Google it. Rust derive public key from private key. Should be something. Ways to generate public care from custom. We don't need a custom input. Crafting a. Oh, there is even there's even a text of crafting a blockchain in Go and Rust, a competitive journey, public key, private keys, and whatever. Yeah. So again, I'm not by far not the first one. Public key from private key in Rust. Yeah. Rust. Looking parties. Yeah. Sorry guys for. Wait. Let me. Yep. Let's generate public private key for custom input. Yeah, I see there's even an article on crafting a. Yeah, but we gotta sign in, so. But for us, keeper and RC gen. Oh. Uh-huh. Key pair. Yeah, we can look up this crate. I hope it could help us, but certified key, signing key generate. Simple self-set. Yeah, we're not going with certificates. Private fields. Generate for. Yeah, I mean, Rust might be pretty, pretty cool when it comes to error messages, but I hate the default documentation because, I mean, there's like you can list it. There's just like function listed here. No, like direct examples, and there's yeah. See here there's something here. Secret key. Oh, anyhow, do I have to like dependencies? Oh, so I can sure up card. Oh, so I can even like invoke directly work with bitcoins. Well, that's not what we want. Result. Secret key and public key. Yeah, I would actually prefer to actually manually. I mean, oh yeah, why? Is there an algorithm we can write? I mean, is it key from key using elliptic cryptography. Is there any way to do it? If out to get elliptic curve, public key from private key. No, they're building from scratch. Oh, yeah, again, there's something. Shit, there's a lot of math here. Point addition, point multiplication, signature verification. But there is basically that everything comes here to the module mathematics to the modules. Yeah. per generation. Yeah, we're generating point multiply carpet. Hashing function Kazakh message sign. Call develop compute where P is the private key and Z is the hash of the message. Well, Z is the hash of the message. One signature consists of the pair. I mean, there's decently explained. It doesn't look that hard here. I mean, especially with the code, it looks more than implementable. But that's not what I'm gonna go with here. So yeah, now I'm gonna yeah. Screw it, I'm just gonna go with an existing crate. And maybe one day, maybe or maybe not, I'm gonna well, yeah, I'm gonna rewrite it on my own, maybe on the next stream. Maybe if this stream is cool, maybe if seed from, yeah, well. So can we run with it? No, we cannot. Oh yeah, obviously. But can I do it actually this way? It seems like I cannot. Oh yeah, but actually I can. Create key pair. Result expects to generic arguments. I think we have an use anyhow. Yeah, we have to just export it. What? The screw it first, and anyhow, we really have to. Shit, we really have to manually import the anyhow. I thought I was sure it's already implemented. I mean, it's not only implemented. I was sure it's like integrated into the compiler itself, but it seems like it's not. So secret key and public key. 250. They seem kind of small, but yeah, they kind of seem too small. Something's wrong here, I guess. But okay, let's go with it for now. Let's go with it for now. Yeah, so we have a key pair. Now what we do is derive public key, derive an account ID. We can go with any hash actually. It's telling me Ethereum is taking the Kazakh 256 hash and then takes the last 20 bytes, which is why not? We could yeah, again, I'm pretty unfamiliar with all the possible Rust libraries and maybe let's go with it. Let's cheat it a bit. And huh? Rent, okay. G, use rent RG core. I think there's a way to go. Again, if it weren't the Rust libraries and the borrow checker Python, it would have been much easier. I mean, hopefully much more interesting for you to watch, but no, we still proceed. Yeah, but it doesn't change the dog shit. Yeah, we still kind of go with it because I mean, this shit suggests something and then tells me no, that's wrong. Then why do you suggest it? I mean, I get it. But... Huh? Okay. Is it a valid syntax actually? Can I start with the? Isn't it what I already got here? I mean, everybody telling me the Rust compiler is cool and helps you. It only irritates me. Which is Phil. Perhaps you want to import it. That's actually what I did. That's just what I did. Just I don't know, like a couple of minutes ago. I mean, I could move it up further up there, but I can go with importing further and further. And yeah, now we're here again. And this shit's driving me nuts. Sorry, dear Rust lovers. Sorry, but it's yeah. Yeah, yeah. You see? G maybe maybe first on the vector, but array. Can it be? Is it the way to? I mean, trying to. It doesn't have a size known at the compile time. Yeah. secret key, the private key we derived, and we turn out everything, and that should be fine. Oh, in fact it is. Why? Oh. That's a cache. Can I go with it actually like this? Will it work? Can I go with it like this? Okay, I cannot. I thought I can, but... Oh. I'll just copy paste it. Oops. Nope. Yeah, so this function should be imported, which means I'll... Yeah, that's exactly the one I wanted, but... Yeah, that's exactly the one I wanted, but... What the shit? It's not the one I wanted, but it probably won't work. Oh, it compiles something. Okay. I can live with that. It compiled. Uh-huh. Yes, we are. Serial as uncompressed from the 12 bytes. I mean, we could cpin address. We can go with it. It will not work obviously because it was auto-completed by the AI, which means it tries to look helpful, but it without actually being the argument. What are these arguments? Um, 6 and beta is a. We actually need the byte arrays. It's actually private key and the public key. Huh? Is it okay that this is a bit 1 byte longer? Yeah, I guess so. I mean, can we go with it like this? Well, I mean, let's give it a try. No, we cannot. Can it be formatted with the default T display? Yeah, so it's uncastable, and that's the problem. That's exactly what I wanted to write the key pair generator myself, because like using someone else's, you're totally relying on them, and we'll gotta Google it now. Sine 32, and that's what we have to go with. That's what we have to go with. So sine modules macros slice U32. Try from. Can I cast it to integer 32? For element. 2. Oh yeah. If converts parity. Oh, it's about parity. It's not about enum parity. We have to find the structs. A struct is public key, and we gotta find the pointer. Oh yeah, that my bad. It's a serialize. Serialize, but isn't it what we're like using here? Yeah, again, cheating with an eye, but there's certain things I prefer not to do, not to bother with. Oh, wait a second. So it wasn't a problem actually with the. Yeah, it wasn't a problem with serializing all the way along. It was the problem was just displaying it correctly. Yeah, that kind of makes sense. Though here's 1 byte more. But okay. Yeah, that's it. Skip the first byte. Why do we have to do it? Why do we skip the first byte? So then take the last bytes and key address 0x. Why did we start with 0x? I have to make a small research on that. It's later. We are turning. Oh, this. type, okay. Code. Go with it. Neither does it work. Yeah, again, it's an AI code. Take the last bytes. Okay, so the printing itself. Oh. Oh, so that also works. So I can just go in. Yeah, okay. Why not? Okay, so the cannot index value of type, whatever. Fuck, someone's doing barbecue outside. And it smells like barbecue. Fuck, I hate them. I hate them. It like the whole apartment like smells like a very good barbecue. Whatever. Copy from slice. Cannot index photo. Wait, let's Google this error. Let's Google it because I really don't know. I really have to know what's going on. Trying to measure this indexing using the following code. Nope. Of type. Huh? Huh? What's wrong with this? Index into a value of type. Yeah, the brackets. What type exactly can't you cast it into? It's just the same. Yeah, that would require some help. Explain what the shit is going on. At least I'm at least there's some usage here. Function must return a hash, a 32, an array of set 32 of bytes. A slicing operation assumes that it's at least 32 bytes long. Yeah, this function likely returns a unit type instead of expected hash value. The typically happens when the Kazakh function is not implemented correctly or the return value is being ignored. However, the struggles is returning nothing. So there's this function which returns obviously nothing, and that's the problem. Hmm. And that is obviously the problem. What does this function actually return? Function. We could I think we could go like with a simple, I don't know, 256 hash. Just screw it. We'll just go with a standard hash. Yeah. We'll just go with another hash. Screw it. Screw this shit. If Ethereum does it, it doesn't by far mean that I have to. Just what is it still trying to use Kazakh? No, we are not using some of these. Okay, can I go with this? No, because uh, just what does it actually? What does the digest function return? Oh, shit! I could have copied from here. Yeah, again, I'm not experienced in Rust. Digest. What does it return? So it outputs a string. So that's not what we need. It's uh CH2 basically, and this is what we're going with. Yeah, it seems more. Oops. Talk store is cool. Okay. Just 6. Adjusting it. Nope, the fucking AI doesn't work. Okay, I'm importing it. Just shouldn't we write like digest? Huh? Yeah. I mean, if an item. I guess we'll just have to import another grade here. Yeah. I believe we can run. Oh yeah. Now we're getting somewhere. We just got our secret key, public key, and our new address in. Yeah, that's something. Though that's maybe not the hash we should be using, but maybe we should be using a less redundant hash. I mean, actually, what's actually how does it how is the collision handled? Public key, then the address is gonna be created. The last step is where collision could happen. Yeah. So yeah, collisions are purely theoretical now. Yes, there are 10 to the power of 48 possible addresses. I fully get it. Most address and balance, code storage means. So they effectively share the same account. Fuck me. Fuck me, that's actually... Yeah, so there's no way of dealing with collisions. Hey! There is not a single way of dealing with a damn collision. There is not a single way. yeah, guys, I'm gonna be stopping the stream for now. I'll maybe get to it tomorrow, but this is, you see, we've already accomplished something. Or, yeah, maybe tomorrow night I'll stream. I don't know. So, everybody have a good evening.